Okay, so we're going to look at a practice test problem similar to number 15. So I'm asked to solve this formula, this polynomial. So the first thing I'm going to do is try to factor it. Alright, so we always factor our first term and factor our last term. So 8 has a couple of factors. I could try 8 and 1 or 2 and 4. Let's try 2 and 4. So I'm going to have 2 and 4. That gives me the 8. I need the x to the 4th, so if I put x squared here and x squared here, now I have factored 8. I factored my first term. The next thing I do is factor my last term. 3 is prime, so that helps us. There's only one factor of 3 that I can have, which will be 1 and 3. So I know that whatever I put on the outside, whatever term gets put here, it's going to be multiplied by 2. And whatever term I put on the inside, it's going to be multiplied by 4. So which one? So let's see. I could put my 3 here and my 1 here. Now, if you don't get this the first time, you would just can't cross it out and go to the next, try a different factor. I think we're going to get it to work here. So I'm going to plug it. Last thing I do is I check my outside term, which is 2x squared times 3, which is 6x squared. And my inside term is 1 times 4, which is 4x squared. And I need it to be 10x squared. So I think, can I add or subtract 4 and 6 to make it 10? And I can. So I plug in my signs. If they're both negative, I want to go through and check to make sure that it all works out. So a negative times a negative will be a positive. And then if these are negatives, it will add to my middle term. So now I have factored my first. Now the next thing I need to do is determine what else I can factor. Can anything else be factored out of this? And if it can't, we go ahead and solve it. So here I'm missing a middle term. So when I'm missing a middle term, I need to look for a specific type of factor called a difference of perfect squares. Difference meaning subtraction, and perfect squares meaning both terms, the first and the last, are perfect squares. So I look here, it's a difference problem, that's good. But is it 1 is a perfect square and x squared is a perfect square, but this 2 is giving me problems. So this is not a difference of perfect squares, so I cannot factor this problem any further. Again, I look here for a difference of perfect squares, and it is not. So to solve this problem, I'm going to set each equal to 0. So 2x squared minus 1 is equal to 0, and 4x squared minus 3 is equal to 0. And I'm going to solve this for x. Here I have 2x squared is equal to 1. Divide both sides by 2, and I get x squared is equal to 1/2. So I have to take the square root of both sides. So here I'm going to get x is equal to plus or minus. Now, I can write this as 1 over the square root of 2, because the square root of 1 is 1. But I remember from a previous chapter that I'm not allowed to have square roots in the denominator, so I must rationalize my denominator. And so what I get is plus or minus square root of 2 over 2 is equal to x. Now remember, these are two answers, plus square root of 2 over 2 and minus square root of 2 over 2. And now we're going to do this problem. I didn't give myself enough room, so I'm going to move this problem up a bit. Here we have our other factor, which is 4x squared minus 3 is equal to 0. I get that from this term. Since this is multiplication, if either one of these are 0, my problem would be 0. And we're going to solve. Here I get 4x squared is equal to 3. I'm going to divide by 4, and I have x squared is equal to 3/4. I take the square root of both sides, and I get x is equal to plus or minus the square root of 3. And what is the square root of 4? 2. So again, this has two solutions. Now, I have two solutions here, and two solutions here. That gives me a total of 4 solutions. I go up here and I say, what is the exponent? It's to the 4th exponent. I have 4 solutions, so I know that I've done my problem correctly.